Excellent. Thank you. And huge thank you to everyone on the panel. We've got Shashank Samala, CEO, co-founder of Heirloom Carbon Technologies, Brian Baynes, co-founder and CEO of Verdox, Peter Reinhardt, co-founder, CEO of Charm Industrial. And in the next 30 minutes, with the three of you, we're going to answer the very simple question of, can carbon removal be done affordably and at scale? Which is maybe more complicated, but I think we'll get pretty far in the next 30 minutes. So the place that I wanted to start is why is carbon removal important to our sustainable transition? And Shashank, I would love for you to start us there.
Awesome. Thanks so much, Candice, for having me. So it's simple. There is no choice between carbon removals and decarbonization. We have to start scaling up permanent CDR today. And if we want to have any chance of limiting temperature rise to the Paris Agreement's targets or reversing climate change, this is also not my opinion. It's the scientific consensus and the view of the US government, who made the monumental announcement that it will be the first government in the world to buy CDR as a customer, along with some other major moves to scale up DAC hubs. So we need carbon removal. It's not either or, it's both. And yeah, super excited to chat more. So would love to have other folks chime in as well, why they think CDR needs to be an important component of a sustainable transition.
I think the short version is we've already overshot, right? We've already overshot on our historical emissions, and regardless of how much we reduce going forward, we just are building up a backlog, and we're gonna have to drain it out at some point. So we got to scale that up, and when you sort of do all the math and look at all the modeling that's been done, it gets huge really fast.
And that backlog gets bigger or worse every day. I mean, this industrial equipment that we put in service 10, 20, even 30 years ago may continue to live another 10 or 20 years. And so all those emissions are cumulative in their impact. And so we have to start not just getting to net zero, but then ultimately remove those cumulative emissions.
And I think that the both and approach, I think, is exactly right. And there are going to be hard to decarbonize areas that even if we get a ton of things right, we still probably will always be needing something like this in the future, right? We're always going to be having more emissions. And so each of you are co-founder CEO of a different type of carbon removal company. You're each taking different approaches. So as concisely as you can you please give us the TLDR on what your company is and what they do? So let's start with Heirloom.
Sure. So Heirloom builds direct air capture technology that permanently removes carbon dioxide from the atmosphere and stores it for thousands of years underground, with a real path towards 1 billion tons of CO2 by 2035. So our technology specifically, it accelerates a natural process that enables limestone to absorb carbon from the air from about time span of years down to about 3 days. So that acceleration is what our technology is really about. We've made history as a company about 4 or 5 months ago together with Carbon Cure, where we stored atmospheric CO2 into concrete. And now we're moving from pilot stage to commercial deployment as we speak.
Excellent. And thank you for that modeling of what the technology is and where you are right now. So Brian, let's go with you and Verdox.
Yeah, so Verdox is developing a single stage all electric carbon capture system. This system's best suited for applications where the source of CO2 is dilute, such as industrial streams with, say, 5% carbon dioxide or less. And that, of course, includes dilute natural sources such as the air. In these situations, the electric system promises up to a 3 times reduction on energy consumption due to the higher efficiency of electrically driven systems versus a conventional thermally driven system. And you can think of this advantage as similar to like why an electric motor in a car is more efficient than a gasoline or a diesel motor. And those later motors have to generate a large amount of heat, which mostly goes to waste. We're based in the Boston area in Woburn, Massachusetts, and announced an initial $80 million capital commitment last year with our launch.
Excellent. And then Peter with Charm.
Yeah, so at Charm, we do biomass carbon removal and storage. And specifically, we take crop residues and fuel load reduction forest residues and cook that into a liquid bio-oil. It's actually the liquid smoke ingredient in barbecue sauce. And we take that barbecue sauce and we inject it into old oil and gas reservoirs as a way of permanently sequestering it deep underground. I guess putting barbecue sauce underground is a uniquely American idea, perhaps. But at any rate, we are a majority of all permanent carbon removal deliveries to date, and have been trying to just scale up as fast as we possibly can over the last few years.
Incredible. So we've got limestone, we've got air with Verdox as well, and the electrical component. And we have barbecue sauce with Charm Industrial. This is a really diverse, awesome crew. And so what we're going to spend most of the rest of the time talking about is how do we scale CDR, right? We're convinced that it's really important to meeting our sustainable transition goals. We're convinced that we need to do it now because there's an urgency here. And we're convinced that the scale is large, right? And so I think first, let's think about how large is that scale actually, and wrapping our heads around that. So Peter, can you share a little bit about the scale that we're hoping to reach?
Yeah, and I think this just has to go back and draw on the scientific consensus that Shashank was talking about at the beginning, which is, what's the scale that we're going to need by 2050 and where are we today? To stay within, 1.5 to 2 degrees Celsius of warming, these IPCC reports have generally shown somewhere around 10 billion tons, a little bit of variance between like 5 and 20, but around 10 billion tons per year of carbon removal to kind of deal with all that backlog and emissions that are already baked in. And so at, 10 billion tons a year, that's a lot of material. It's about 25%-ish of all the emissions that we make every year right now. So it's a huge amount of material getting moved out of the atmosphere and back underground. And to put that in the context of how much is getting delivered today, probably on the order of 10,000 tons a year is getting delivered today. So, we're talking about many orders of magnitude growth. It's something like 70% compound growth for the next 27 years to get to that scale. And to put that growth rate in context, that's twice as fast as software grew over the last 30 years. So it's a staggering kind of scale up and deploying physical infrastructure as we go. And this is in the broader context of basically needing to rebuild all of our physical infrastructure, or a huge proportion of it, to deal with climate emissions broadly on the reduction side. So it's a huge amount of growth and a huge amount of infrastructure that has to be rebuilt or built for the first time.
I actually got chills when you said twice as fast as software grew in the last 30 years, because software, I don't know if maybe the last 30 years wasn't like the heyday of it, but it feels like software grew pretty quickly in the last 30 years. And when we're talking about infrastructure, that is a wildly different thing to be talking about. So thank you for grounding us in that. Yeah.
Yeah. And I think we have to understand just like what kind of wartime footing that puts us on, right? And maybe to slide a little bit into the next topic of like, what are these biggest challenges that we're dealing with? Like in wartime, you don't deal with permitting, right? In wartime, the government says, go, do whatever it takes. And we can't be kind of tripping ourselves. Like wartime footing is like, how do you get to 24/7 operations? How do you start manufacturing on 24/7 basis? How do you start operating on a 24/7 basis? Can you even start designing on a 24/7 basis? Like, does the finance department ever shut down? That's what wartime means. And I don't think that we have really internalized what that wartime footing means when we think about things like permitting, where if we're talking about like multiple years reviews, where like the NEPA permitting system, by the admission of many environmental groups, is like to slow things down, like that's not going to work if what we need to do going forward to save the environment actually is to go fast. And so I think there's a huge amount that needs to change about permitting to like actually enable this to happen. Otherwise, we're kind of lying to ourselves about whether we're on a wartime footing or not.
And we're going to dig into more of this. So just to ask this question now, and then we'll dig in more, but like, who controls the permitting? Who could actually make it a wartime, switch that flip on that?
I think it's at all levels, actually. I think you experience it at a city level, you experience it at a county level, a state level, all sorts of other jurisdictional levels through the EPA and otherwise. I think the one that has been talked about the most probably is NEPA permitting. I mean, even just today, there's pretty interesting discussion about how, the shale gas boom, fracking, was enabled by, I think, a categorical exemption for shale gas fracking. But still, when you do solar or nuclear or any of these other things, you still have to go through a huge NEPA process. So like things like that are where we're just shooting ourselves in the foot in terms of actually being on a wartime footing towards the thing that we want.
Right. We're almost doing the opposite. If shale gas fracking is passed through, but everything else isn't, kind of counterintuitive. Excellent. Okay, thank you for the framing of the scale, and then the biggest challenge on your side. So, Shashank, let's talk about what you would identify as the biggest challenge to scaling CDR today.
Yeah, so in CDR, it's about scale and low cost, right? And you can, and they have, you know, there's feedback between scale and cost, because scale cost is many times a function of scale. So I think the first order of business is ensuring that we have an easy path to scale. So just continue on Peter's point. NEPA is an interesting example where basically the same toolkit that environmentalists use to ensure to stop fossil fuel, to hinder fossil fuel production, is also the same toolkit that we have right now to permit these solar, wind, nuclear, CDR projects. So I think fundamentally there's something wrong there, right? And because we are basically hindering ourselves to advancing the principles of the environmentalists, which is protecting the environment. So that's one. And personally, we've seen all sorts of opposition, all sorts of bureaucracy, political infighting at the local level, state level, as we were building projects. I think it is hard to understate the importance of that. And a lot of the times we talk about technology and costs and design decisions and offtake and credits and all that, but at the end of the day, it's if you cannot build out there, it's going to be very tough. And then number two, I would say, is long-term bankable offtake. Well, I'm sure we'll talk more about creating a bigger market for CDR. What enables solar and wind to really be deployed at scale is not just the demand signal, but rather a fixed price, long-term power purchasing agreements that were bankable, and that unlocked trillions of dollars of infrastructure investment. Like last year, we spent about $900 billion on renewable energy projects, and that needs to happen on CDR as well. So there's a few customers who are leading the way on what those bankable contracts look like. And there's a lot of education that's happening right now to bring the lessons from solar and wind to CDR. So that's really important, ensuring that these contracts are 10 years, 15 years, long-term, stable price signal. And I think, number three, I would say, is and it's sort of connected to permitting in many ways. We will never reach gigaton scale without the trust of the communities we stand to serve. We need to do more than create good jobs. We need robust community engagement and the way to evolve and create evergreen community benefits. I think there's some. I think permitting and community benefits are tightly correlated, and I think there's some movement we can do as industry, as climate community forward, where both of them can live together. So because a lot of the opposition to permitting is because the communities where we built these oil and gas plants, we didn't do right by them. So we need to figure out how there's a newer world, newer future, positive future that we're creating for them.
Absolutely. Yeah. So long-term bankable offtakes, and then trust of the communities, I think, were the main things that you were talked about for scale and low cost. And I want to circle back on some of these, but first, Brian, would love your thoughts if you have any other additions to add to the challenges, or the main challenges that you see, or if you wanted to add on to anything that was said.
Yeah, I love what Peter and Shashank said. I'll just double down maybe on the cost piece. Mm-hmm. I think if we look at the success of some of these other industries, which did eventually get to a critical mass and did start to scale rapidly, I mean, certainly a lot of the elements that were talked about were critical components of that. But at the end of the day, the economics had to make sense. And we're not yet there in the carbon capture industry for a lot of these projects where somebody's demonstrated at a reasonable scale that you can make a profit. And so it's a critical next step in our industry's growth. And a lot of folks that we could draw into this space, a lot of sources of capital, a lot of sources of political influence, a lot of potential employees and other stakeholders, when they're going to watch these first few projects that are getting built thanks to the government, U.S. government support, and some other projects that will be started globally, and they're going to see what's happening. while that's going on, I would really encourage for the VCs in the audience, for the entrepreneurs and aspiring entrepreneurs, and even for the governments, I would say, listen, the door still is open here for more innovation in our space, for fundamentally different ways to think about this and to try to drive those costs down. So in direct air capture, for example, we're still in the single-digit percentage of thermodynamic efficiency. So you could make a 10x improvement potentially here in the energy use in these processes, and then hopefully in the cost, by a more ingenious approach. Not just because we haven't been smart enough to figure it out yet doesn't mean it's impossible. Okay, so I would love to see folks think more boldly and come at this problem with cost as the goal. Maybe efficiency is one of those things that could light a path towards that lower cost, and then that's ultimately going to help us make the financing easier, get the communities on board, get the governments on board, and push us to these billions of tons that we all need to capture.
So we're going to go pretty deep on the creating the market, on the cost side of things. What I wanted to double down on right now, or double click on, is permitting community engagement, because it does sound, and Shashank, you said this first, that there's this sort of feedback loop between the two of them, right? Where if the community engagement isn't there, and if the community doesn't want you there, it's a lot harder to get the permits there. And that's a big focus of the IRA with Justice 40. There's and rightfully so, right? We want a lot of the community involved in this. And there's some distrust, and there's also this undertone that I'm picking up, which is clear in the carbon removal space, that it can often be talked about from an environmentalist perspective as like we shouldn't do that, right? We should first get rid of fossil fuels. We should first do these other things, and clearly we're all saying yes, and right, like we can do both things. We can do two things at once, as long as different people are doing different things, and we mobilize all of it, right? We want to scale CDR, and we also want to scale everything else in climate tech at the same time, right? Not competing. And so I guess I just wanted to think more, or ask really, how much of this is like a marketing around carbon removal? How much of it is just, this is permitting in general for any sort of space and climate? And is that something that we should be kind of taking out as a through line here, is that communicating carbon removal, if we could communicate that better, then some of these things would get easier as well.
Yeah, I think one thing we struggle with is, I think direct air capture struggles with, is conflating direct air capture with carbon capture and storage. Right now, for a lot of these communities, carbon capture is just one, all-encompassing term. And I think CDR overall, not just DAC, is falling into that perception of these communities. In general, given there's a couple of companies involved in this space that are where DAC is highly tied to oil and gas. I think that is only reinforcing that sentiment and creating more distrust in communities. And at least something that we're working on is like, how do you start creating a wedge in that perception between direct air capture and CDR and CCS and oil and gas? Because that's an important wedge, because if you talk to communities, if you go into the ground and show them who you are, your history, how your company came about, your values and principles, and why you're doing this, it's very different than the narrative that oil and gas companies have said and will continue to say. So I think that is an important thing that we as an industry need to figure out. How do you create a wedge? How do you educate and create awareness for the kinds of companies you're seeing in this panel today, where we are driven by getting us to net zero and creating a better future for us all, and protecting these communities, taking them with us into the future, instead of creating more harm in their communities and neighborhoods. And it's really sad, honestly, because we share the same principles as they do, but I think there's just a lack of education and awareness. So
I think there's also an open question of like, what does a great community engagement program look like?
Yep.
Like, what's the prior art here? Like, the prior art isn't great. The prior art is like really bad outcomes in many cases, not all cases, for the local communities. And so does that have to be co-invented at the same time? And is that necessary, or can we maybe extend some trust that if we're having a positive climate impact, that there's good intent behind some of these other pieces as well, and give a little more runway to like simultaneously co-invent how a community engagement process should be run. Maybe there's some prior art, but I think even companies that have tried, like there was a direct air capture company that tried recently to do some community engagement, and honestly, it, I think, set them back quite a bit. Through miscommunication and other things that maybe happened around that event. So how to do it well, and how to like find communities where people are eager to maybe get started, and stay away from communities that don't want it right now, and let them be later adopters. So I don't know what the right path is there. I think this is super important to figure out, and super important to have local communities really engaged and bought into things that are getting built in and around where they live and work. But the path to do it is actually not clear. And I think that's an opportunity for quite a constructive process and quite a constructive set of like literature and documentation and job creation. Like every single one of these companies involved in this massive industrial transformation that has to happen is going to need a team of people that are doing this and working on this and figuring out how to do it well. So it's a whole new job category, honestly, that needs to get created, and we need experts that know how to run these kinds of processes and figure out how to do it well.
Yeah. I think it's ironic that oil and gas maybe work great at community engagement with some shady promises that now make it harder for people with decent intentions to get things done. And it does remind me of there's some bridge that was created where it was just like wartime, like we got to do this, and it was built in like a record time. And the one thing that they did instead of permitting or community engagement was like every job is going to be unionized, right? And like they had this one rule that was helpful and helped with community engagement, but was different, right? It didn't require all the hoops to jump through. Not to say that's like the solution, but I think getting creative is definitely part of the solution here. And I think, Peter, like what you said, there's such an opportunity for anyone listening who has any thoughts on community engagement to get involved here and like to actually drive this a new way of engaging with folks at the community level.
And maybe I'll highlight one researcher who I think is doing really great work here, which is Holly Jean Buck. She recently published, honestly, something that largely agrees with kind of think the direction that we're thrusting here, which is like, if we're going to fix the environment, we probably need to get out of the way of the projects that want to fix the environment, or at least have kind of a productive discussion about how we're going to get these things deployed. And it was a bit of a call to action, I think, in the world of community engagement, which I really appreciated. But I think there are great researchers in this area, and we need to figure out how to have many, many, many more of them.
Yeah, and how to connect the dots. I think it seems
Yes.
like the people doing that and the people like you all that are building the solutions. Excellent. So we've covered actually a lot. We've talked about challenges around permitting, social willingness to build, technology enablement as well. And I want to dig into essentially like the overall market, the cost, the willingness to pay. And my understanding is, we're working mostly in a voluntary market, and we're maybe moving toward more compliance procurement markets that are being built out and will be hopefully built out. But yeah, let's dig into this. So first question is, what is the size of the market today? Where does it need to go? I think we've already touched on some of that, Peter, right? That like it just needs to be scaled up. Is there anything else that we want to add to like the actual on the purchase, like on the money side, right? Like we've got the scale on the infrastructure side and the physical side. But what about?
I think you can look at the curve of purchases that have even happened over the last few years, and it's crazy exponential, right? Like the first purchase ever of permanent carbon removal, as far as I'm aware, at least of any material size, was like 2020, when Stripe had their $1 million set of RFP, and they purchased four chunks of carbon removal, and they've since scaled that up. And then Shopify followed in tightly behind that with a bunch more purchases, and Microsoft with a bunch more purchases, all in 2020. But I think in aggregate, it was like a couple $1 million. Like it wasn't like that was the very beginning. And now this year, I think you've got hundreds of millions, probably low hundreds of millions of purchases and commitments happening now across both corporate buyers and, as of last week, as Shashank mentioned, like the U.S. government actually saying it's going to purchase carbon removal for the first time. So that's a really steep curve in demand. And I think what you see is a lot of supply scrambling to catch up now.
Shashank, would love your addition.
Yeah, right. It's sort of interesting, right? It's like I get a question. It's like, is the market supply constrained or is it demand constrained? I think in the short term, medium term, it's always supply constraint because these are big projects that need to be built. But medium to long term, it's definitely the demand signal that these large corporate buyers have to send. I think we have a pretty good footing for voluntary carbon markets. Like it's growing. There's more and more folks coming in, and more and more folks need to come in. But we're starting to. We need to start putting down infrastructure for what procurement markets from the government and compliance market looks like. Because ultimately, we think 80-90% of the demand 10 years from now will have to come from those markets. When the governments actually start putting down clear regulations, clear limits and caps on emissions on big heavy industries like cement and concrete and aviation and oil and gas and so forth, like that's where really most of the emissions are. And unfortunately, the carbon abatement cost in those markets is too high for their willingness to pay. So that's why you have professional services and technology and so forth who have lower emission footprint but a higher profit profile taking over the initial adopter. That's what's happening right now, but it needs to transition there, and only governments actually have the ability to create those markets.
Excellent. Brian, I would love your thoughts. So the picture that Shashank just drew for us was that essentially in the short term, supply is maybe more of the constraint, but actually in the longer term, it's the demand and the large corporate buyers. And so would you agree with that generally? What's your take on this?
Yeah, I generally agree with that. I think that, in the short term, there's only a handful of buyers that can afford to pay prices that make these projects reasonable in terms of their return profiles, or at least they don't lose too much money. But in the long run, if this industry is going to get to the scale we're talking about, the cost has to come down substantially. And at that point, we have to do a lot of market development. But we think there is a very, very large market there. And that's, the promise that the whole sector holds, and why we're thinking long term as we look at these initial projects.
Excellent. So I want to jump into CDR credits, how they're structured, how they're purchased. And then Shashank, something that you mentioned earlier was just, how do we deploy some of these larger scale projects? And I think, it might be related to this, might even bring in advanced market commitments as a potential, accelerant to some of this. But yeah, would love to just learn how the credits are created today and how we think that they could be created better in the future.
So today, there's a MRV process. There's a measurement, reporting, and verification, and that MRV process is different for any CDR pathway. There's a different protocol, and those protocols are being established today. There's lots of science and industry coming together to establish those protocols. And that will change over the next few years. In terms of building today, right? And I think an important thing that we need to learn from solar and wind is innovation via deployment. Like we have to learn by doing, and we have to build today and learn from it. We can't just sit in a lab and wait for all the efficiency improvements and look for the next breakthrough. We have to build. There's so many things that happen when you start actually building. Right? It doesn't just take technology. It takes community engagement, renewable energy procurement, storage providers, all these ecosystem things that need to come together. And costs are also a function of all those things too. So I think, when you talk about actual specifically technology, it's only a small part of the cost stack. So we have to build today. And I think that's where advanced market commitments come as well, where, you're creating this strong demand signal with high prices, just getting companies to go build and learn. And I think that just is so catalytic. And I'm sure Peter has more thoughts on this too.
Peter, your 30-second thoughts, and then we'll have to wrap.
We have a slightly different challenge, I think, than a lot of the other carbon removal companies in the sense that we build small machines and build them in large numbers. And so I don't think we face quite such the same constraints and challenge of like short-term versus long-term supply. And then that revolves then into how the credits get structured. So I think for us, we are interested in just selling out as far as possible because it gives us clarity on how much manufacturing capacity and so on we need to build. But for us, it's a much more continuous process. So I think over time, hopefully people get more and more comfortable with signing agreements that aren't just 1 year or 2 years or 3 years, but more like 7 years like Frontier is doing, or more like even 20 years like often happens in more mature industries.
Excellent. I think that's a great nuance. We are going to end with each of you sharing one sentence on what you want people to take away, right? If it's like, here's what I want you to focus on in the audience, whether you're deep in CDR, new to it, what's the takeaway? So Brian, we're going to start with you.
Yeah, we still need substantially cheaper, simpler carbon capture processes. We can't be afraid of the tech risk. Let's double down. Let's try to find the next generation of solutions here.
Excellent. Peter?
We've highlighted some of the biggest problems in the space, which we think are permitting and community engagement and getting those right. So if you're interested in CDR or the climate transition broadly, those are the areas for impact.
100% agree. Community engagement and permitting are number one things to tackle. And after that, it's learn by doing. Let's build projects and learn, and let's build more and iterate and learn again.
Cool.
What counts as carbon underground? +1.
Love that. I'm going to add in workforce. I think like the demand for operations engineers and the people like actually building this is super interesting long-term as well. I second that. Let's build and let's do this. Let's be bold and get shit in the ground. Excellent. Thank you. Thank you all for joining me. This has been awesome. I've learned a ton, and hopefully you all have had fun on the panel and also in the audience.